Okay, guys, today we are going to solve a Cambridge IGCSE paper 6. This is ATP paper, and this is a 0625 slash 61 May June 2023 1 hour paper. And let's start off with our question number one, which states that a student investigates the balancing of a meter rule. Figure 1.1 shows the setup. Okay, so after looking at this, there is XP is the load. Okay, pivot is at 50 centimeter meter rule. The IT. Okay, the student places the meter rule on the pivot at 50 centimeter mark with the scale of the ruler facing upward. He places an object Q with the center on the meter rule at 90 centimeter. Calculate the distance y from the center of the Q to the 100 at the end of this. Okay, so this is going to be okay. 100 minus 90 is going to be what? 10. So this is going to be 10 centimeter. Units are already there. Okay, the student places load P of weight P equals to 2 newton on a meter ruler. He adjusts the position of the load so that the meter ruler is near as possible to be in balance. He measures the distance x from the center of P to the zero end of the ruler. He repeats the procedure using load of weight P 3, 4, 5, and 6 Newton. The values of P and X are shown in the figure table 1.1. Describes the main difficulty the student has when doing this experiment as accurately as possible. Okay, so for number one, it's going to be ruler must be balanced. Ruler must be balanced. This is going to be the first one. Then it's going to be difficult to get the right load for the meter rule, and it is also going to be difficult to judge the center of mass. So these are the points. So it has only one mark, so you can write any of the one from these. Okay, moving to the next question. Plot the graph P on the y-axis, P which is newtons on the y-axis, and X on this. Okay, so drawing these values over here, so you can easily get a graph like this. Okay, let's roughly sketch this graph. P into, this is the unit, this is X, and this is going to be in centimeters. So if I draw these label, this is going to be 10, 20, 30, 40, and lastly it's going to be 50 centimeter, and this is going to be 1.2, 2.4, this is going to be 3.6, and then it's going to be 4.8, and last is going to be 6. Okay, so when you plot these graphs, or values, so it's going to be like this. So the graph would be the curve would be like this. Okay, okay, this is going to be the best fit line. So again, you have to draw the line like this. Okay, so equal number of points above and lower, or the maximum of number of lines, maximum number of points that the line is touching. And this is, use the graph to find out the value of x requires to balance the rule P equals to 3.5 newtons. Again, you have to see where is 3.5 newtons, for example over here in the graph, and then you have to find out the value over this one. This is the required value, and which is going to be 26.5 for my case, and 26.5, this is going to be centimeter. Using the apparatus for from figure 1.1, explain briefly how would you determine the position of the center of mass of the ruler. So how we are going to find out the center of mass? We are going to balance the rod, the meter rule, to find out on pivot So this is going to be again, if you balance the meter rule on a pivot, so if the clockwise moments and anti-clockwise moments are same, so that point is the center of mass. Or you can do one more thing, that if the object is in equilibrium, so yeah, again this is going to be uh, pivot will be at center of mass. Okay, moving to the next question. A student investigates the cooling water under different conditions and shows the setup. This is the setup. This is the thermometer, shows this is this. So you have to record the reading. So this is going to be 21 degrees Celsius. So this is the right answer for this. And then we have the student pours 200 centimeter cube of hot water into the beaker. She records the temperature theta of the hot water at time is this. Starting at this, she continues the recording at 30 intervals. So again, this is going to be second. This is going to be degree Celsius. You have to complete the heading. Now completing the table: 0, 30, 60, 90, 120, 150, and this is going to be 180, because it stays at 30 seconds of interval. So for every 30 seconds you have to add the value. Calculate the decrease in temperature from T this and this. Again you have to take this value and this value. So 92 minus 67 is going to be 25. So this is going to be 25 degrees Celsius. And then you have to find out this, and delta theta over delta t. Delta theta is what? It's going to be 92 minus 67 upon 180 minus 0. So it's going to be 0.138 degrees Celsius per second. So I would write it two significant figures. So 0.14 or degrees Celsius over second, or you can write it down 0.138 degrees Celsius per second. Okay, but this is the right answer. The student states that the average rate of cooling of water decreases as the temperature comes to new room temperature. Suggest one change to the experiment that you could make to test the statement. So we will take the temperature till room temperature. So obviously they are in equilibrium, thermal equilibrium. So they would, when the temperature of the liquid and the surrounding is same, so obviously there will be no change in temperature. Suggest how to display the result to make it easier to see the trend in the rate of cooling. So what you can do is plot the graph, and that graph will be again between temperature versus time. Okay, explain briefly why it is good practice to read thermometer scale at right angles, because we have to avoid parallel x error. Parallel x error. The student uses measuring cylinder to measure 200 centimeter cube of water. Hot water. She reads the scale at right angles. Suggest another precaution to obtain an accurate reading of the volume of the water. So this is water. Read the lower meniscus. Read the lower meniscus. Or you can see this measuring cylinder. Put the measuring cylinder on horizontal. Put the measuring cylinder on horizontal surface. So obviously if you don't put it on a horizontal surface, you won't get the right reading. Okay, A student investigate the refraction of light using a semicircular transparent block. Figure 3.1 and 3.2 shows his ray trace sheets. Okay, on the figure, draw the normal NL through the center of AB. Again, you have to do what you have to make with the help of scale. Draw the center, and that is going to be your normal, so you can write it down NL like this. Continue with the normal so that it passes through the curved surface of the block and label it NL. So we are done with this, point C where the normal NL crosses AB. So we are going to put C over here. So this is also done. Draw the line DC below line PC at an angle of 30 degree to the normal and to the left of the normal. Okay, so now you have to draw a 30-degree. So this is going to be like this. Again, use the protector to draw this. So this angle is going to be 30 degrees. So this is your basically angle of incident. So draw this is done. The mark a neat crosses x of the for two position on line DC and label the position P1 and P2. Okay, so what we are going to do is we do this. You have to add x over here, and then you have to do what, P1 and P2. You have to write it like this. Okay, so this is also done. The student looks from the position of the eye shown in figure this to observe the image P1 and P2. He adjusts his line of sight until the image P1 appears one behind the other. He places two pair P3 P4 between his eyes and block so that P3 and P4 and the images of P1 and P2 see through the block appears one behind the other. The positions of P3 and P4 are shown in the figure. Draw a line joining the P3 and P4. Continue the line to AB. Okay, and you need to label it E at the end of the furthest test. Okay, so now you have to do this. You have to draw another line that you need to connect it like this, P3 and P4, and then you have to draw straight line. Continue that straight line like this and mark it as E. Okay, and then you have to do what we have done, this E as well. Okay, so what else is there? Measure the acute angle alpha. So again, you have to measure the acute angle alpha between NL and CE. NL and CE. NL and CE. So this angle you have to measure. I am shading that angle which you have to measure. Again, you have to use a protector to measure this angle. And when you do that, so it's going to be 49 degrees. Okay, so it's less than that. So we will write 49 degrees over here. State one precaution that you would take in order to produce an accurate ray trace. So again, can use the sharp pencils. Just me. View from the base of the pens or bottom of the pens. Okay, and one pen must be vertical, pens must be vertical. So any of these out of 3 points you can write anyone to get 1 mark for that. Okay, the student moves the transparent block to a new position on the ray sheet as shown in figure 3.2. So now he has changed this position. He places P1, P2 on line DC in the same position used in B2. Okay, he observed the image P1 and P2 through the curved side of the block. He places P5, P6 between his eyes and block so that P5, P6 and the images of P1 and P2 seen through the block appears one behind. He draws a line CF through the position P5 and P6. Measure the acute angle beta between the line AB and CF. So line AB and CF. AB and CF. Okay, so this is going to be your normal. So if you draw this angle, or if you measure this angle again, so it's going to be 20 degrees. So this is the required angle CF and AB. So this is going to be what? 90 minus 20 is 70 degrees. So I will be writing 70 degree over here. Okay, unit is already there. Calculate the angle theta between CF and AB. Now you have to find out the angle between CF and AB. So already we have done this. So this is going to be 20. 90 minus 70 is going to be 20. A student suggests that the angle alpha, which is what? Angle alpha is what? Oh, hold on. Angle alpha. Okay, yes, angle alpha is 40 degree. We have done it in the it's 49 degrees. Okay, okay. Angle alpha is 49 degrees. Should be equal to angle theta, which is 20 degree. Okay. State whether your results or support the suggestion, justify your answer. So this statement is wrong. And why is this wrong? There is a huge variation or difference between these two numbers, and you can also write that it's the beyond the limit of experimental accuracy, beyond the limit of experimental accuracy. Okay, moving to the next question, and in this question, this is again 7 mark question, and you have to again highlight few of the things so that you can understand. A student investigate the change in the resistance of a lamp when the current in the lamp is increased. Okay, so what is investigating? Change in resistance of a lamp when the current in the lamp is increased. These are the following apparatus. That is, apparatus is going to be a power supply, low voltage and ammeter, voltmeter, connecting wires. Other is also apparatus is normally found in the school library. Plan an experiment to investigate the change in the resistance when the current in the lamp is increased. Resistance R is given by this. We cross this. You should draw the diagram used. Okay, let's do these things in steps. Okay, now we are going to solve one by one each bullets, and then we are going to sort it out how things are going to be, and then we are going to make a paragraph. So first thing is this, that you need to just a second. Okay, first thing is that you need to draw a diagram. For drawing a diagram, you should be looking at these apparatus which is already given to you. So you should mention all these things into your diagram. So you can see this thing. There is a power supply, there is a low voltage filament lamp, then there is an ammeter, there is a voltmeter, and these are the connecting wires. And I have added a switch over there because when we require the current, we can easily switch it on, and when we don't need that apparatus, so we can switch it off. Okay, this is done, and then we are going to explain how to do the investigation and how to change the current. So how do you are going to do the investigation? In this, you have to tell us how you are going to set up your circuit, and when you are going to change the current, so you have to use this formula. So to find out the value on the voltmeter, basically this is how you are going to find out the values from here. So let's see. If you want to find out this value. So you will be checking the reading on the voltmeter. For the current, you will be checking the readings on the ammeter to find out the change in the current and how you are going to change your current. Next is draw the table with columns and headings, and this is the table that you are going to be making in this experiment. But again, you are not supposed to put the readings over here or values anything. And in the last, that is basically you need to explain how your readings should reach a calculation. So basically you are going to make a graph against resistance, voltage, and current, or you can draw a graph between resistance and current to find out the your desired requirements. Again, remember this thing that you need to repeat this experiment with two different current values so that you can easily find out the answer. So I hope this is well explained, so you guys can write it down in the paragraph. And thank you very much.